Greetings, welcome to the second recap of projectDIG. projectDIG is a 2D multiplayer automation survival sandbox that I'm developing entirely here on Twitch and uploading the VODs to YouTube. Most people will be watching this on YouTube. Welcome. Like I said, this is the second recap, so we'll be going over what has happened since the first recap. And I'll have a link to the first recap. You can find it very easily. So, lots of progress have been made. I started working on the physics like immediately after the last recap and just failed all over the place. And so I just kind of like gave up on that for the time being and moved on to some easier things. So we worked on several like utility classes. So we implemented a vector class, which I pulled over from Kriya, which just allows us to operate on coordinates, x and y coordinates, and we added in testing for that. And so you can do lots of basic stuff on it, multiply them, add them. One really cool thing that this vector supports is the underlying type is templated, as well as the unit of that vector. And so we can have a float vector, which is a float in pixel units, which is just 1, or a pixel vector, which is an integer in pixel unit. Or you can have a tile vector, which is an integer with the tile units. So you can move around in the world, or like have your coordinates be in this tiles or blocks unit space. So that's super useful if you're wanting to be able to go back and forth between the two. It has converters automatically for them. And I also did the same thing for the rectangle class, which is right here. Yeah, it's same exact stuff, just being able to manipulate them, move them around, resize them, check to see if it contains a position or a rectangle for intersects. And then we moved on to some more interesting things, specifically the write stream and read stream. So this is for serialization. We needed to be able to serialize data if we're wanting to read and write stuff to disk, or also for network later on. And so with the help of some viewers, we're able to come up with a very tight implementation where we broke apart the it was originally called a data stream. Now it's a write stream and a read stream, and they have very different operations. So a write stream has the L-shift operator to be able to write data to it, and so you can easily just like write an integer or string, whatever, and it's templated, so it automatically creates this template value for us. But a cool thing is that we say somewhere in here, oh yes, here we go, that it's only available if it's trivially serializable, and then we can specify certain types to be that, such as our vector, which is somewhere, oh that's right, I think I put in our types. Yes, here we go. So we just say those are serializable, and so it can automatically create that templated serialization for us. And then, so that's our write stream, and then our read stream. So our write stream, we're writing data to this buffer, our data, and then our read stream is just the const data. Where is that at? Read stream. Where we're reading data from it, so we don't actually ever want to modify that, and we're just pulling out data. And so it's really just tracking where we are at, how much space has been allocated for this data. And so then we did I'm going a little slow here. I'll go faster. We implemented some events. Just super simple callbacks. We can register a callback and have these events invoked, so it's like a group of callback functions. It's really basic. Then we did some hash strings, string hashing, lots of fun stuff. Still have to figure out some things for that, but it's working for the most part. Like, we can hash a string and then we can use that hash for a key, and it can store. I need to do some string interning, but I haven't done that yet. And then we get to some more of the meat resources. This is, I think, one of the coolest things that we've done in the last 2 weeks, which is our resource system, where we can request a resource to be loaded, and it will immediately return a resource handle for that resource, and it will asynchronously start loading that in the background. And we added just after that the file IO, and I'll go over that. But that's really cool because then we can start loading something and we have this resource handle, and we can then come back to the resource system and say, hey, give me the resource that belongs to this resource handle, and it'll give it to us. And it might be valid or it might not be. And so like that's where our BGFX texture handle would be set. And if we look at the implementation, we can see what we do is that as soon as the file finishes loading asynchronously, it calls this callback function, which will end up being the corresponding type callback, so either audio or font or shader or texture. And it will then provide also our handle that we can then use to say, okay, get the handle for this resource and set the texture handle on our texture resource. And that's what we are doing here. So that way in the future, whenever we request the texture resource, we actually have the handle set properly. And if it's not set, that means it's not loaded, which means we can just say, okay, well, let's not use this yet. Let's not render this texture. And that gets us into our file IO, which we spent 2 days on. And that's again, I try to simplify it as much as possible. You can save and load files, and you can do that both synchronously or asynchronously. And in the back end, we have a file system that has 2 threads that are being spawned, and they're running constantly, waiting for, well, they're waiting. Like we're using a conditional variable to wait for it to be notified, and whenever it is, that means that we have something to be saved or loaded. We then wake up that thread and let it do its work. And yeah, we're actually using our read stream and our write streams in that. It's all working perfectly. It's great. Which brings us to the last part of this recap, which is fonts and rendering. So our render system has received a massive upgrade. So originally it was just being able to render a few things, and that's it. But what I did is I went through and I added in this concept of layering, and so we can have this callback be registered. Well, let me actually step back a little bit. So we have this world component. A world component, if you remember, is a component that's associated with the world and not with the individual entities. And so we only have one world component per world, and we use that in our render system. Now, it's not technically in our render system. It's spread throughout, but we have our render layers now. So any systems can write to our render layer if they want to, and it can say, hey, I have a render layer, here's the index, here's the viewport, and here's my draw function. And so it can kind of register this callback to some degree. This is like, hey, whenever you're going to render, here's what I would like you to render. And so we ended up doing that with our physics system. We have in here, down at the bottom, we have our physics debug, which, I think that's right, yeah. Which gets added, it just has a draw function. And so this is this one actually is a little cheating. Let me show the other one. It's a little bit better. So our entity layers, that gets rendered, or it gets scheduled with our scheduler system, which I recapped in the last video. And it just claims that it's going to be writing to the entity layers and transforming the component and render component. And actually, I just realized I missed something here, which I should add in, which is that we are also going to be changing the render layers component. And so what we do is we get a, or actually we're not doing a hash right now. Yeah, we go through all the entities. We kind of sort them by what layer they say they belong in, and then we create a new render layer for each one of those. We push it back and we say, hey, this is our draw entities, and it then is going to be, or whenever we actually render, it's going to call this function, and we're going to go through all of our entity layers and actually render out each entity that belongs on that layer. And so if we go back to our render system, you can see our render function now is very simple. All it does is it goes through all of our render layers that we've added since the last rendering. We then sort them by their index, which is essentially their like Z yeah, their Z, and then we finally just go through each render layer and render it, draw that layer, which calls that draw function right here, and then we submit that layer, which actually goes through, and with this we have all of the sprites and shapes and everything being batched together as efficiently as possible, and it's awesome. So that's going to be it for the recap today. I think I probably went way over what I intended, but at least I was much more thorough than I was last time. If you have feedback on this, please leave a comment. I'm definitely looking to improve these recaps over time. I'm sure we're going to make a lot of them. So yeah, please give me feedback. And yeah, I just want to also thank you, all my patrons already. I've had a good amount of support, which I really appreciate. Thank you guys. I'll leave a link to my Patreon where we have a goal that we're actually really close to. I'll be doing these, if we reach it, I'll be doing these recaps every week. And yeah, so thank you guys. I hope you have a good one, and I'll see you again soon.